The temperature at dawn was 8 degrees Fahrenheit and increased steadily 2 degrees Fahrenheit for every hour. The equation y equals 2x plus 8 gives the temperature y after x hours. State whether the relationship between time and the temperature is proportional or non-proportional, then graph the function. So we need to do two things. We need to graph this equation, y equals 2x plus 8, and say whether it's proportional or non-proportional. So the equation makes sense in the context of the problem. It starts at 8 degrees Fahrenheit. That's the plus 8, the y-intercept. And it increases steadily at 2 degrees Fahrenheit. That's the slope. So right away we know that this is going to be linear because it is written in slope-intercept form. It's written in the form y equals mx plus b, where m is our slope of 2, and our y-intercept, our b, is 8. So I know that this is going to be linear because it is written in slope-intercept form, and equations that can be written in slope-intercept form are linear. I also know that this is non-proportional. How do I know that it's non-proportional? It's because b does not equal 0. For a relationship to be proportional, it must go through the origin, meaning the y-intercept would have to be 0. In this case, the y-intercept is 8, so I know that this is not a proportional relationship. This is non-proportional. Okay, so the other thing that I need to do is graph it. And there are a couple of ways that I could graph this. The easiest way is probably to start at the y-intercept, which is 8, and then count the rise over run. The slope is 2, so I could write this as a fraction, and I could go up 2 and over 1. That is definitely the easiest way to do it. I would only need to get 2 points, so I could just do the y-intercept and then go up 2 and over 1 to get the second point. There is another way that I could do this, either using a calculator or just using your noggin, which is I could pick a few values for x and just substitute those values in for x. For example, what if x was 1? My equation then would be y equals 2 times 1 plus 8. So y equals 2 times 1 is 2, and 2 plus 8 is 10. So when x equals 1, y equals 10. So I could use the point 1, 10. And because I need 2 points, we could pick a different point for x or a different coordinate for x. Let's just use x equals 2 just because it's a low number. You could use anything you want for x. I could use 1.375 if I'm a maniac, but let's keep things easy for ourselves. Let's just use x equals 2, so we'll substitute 2 in place of x. So then we've got y equals 2 times 2 is 4, and 4 plus 8, of course, is 12. So when x is 2, y is 12, so I can also use the point 2, 12. Now, to be clear, this is a longer way to graph this than just using slope and y-intercept. Using slope and y-intercept is definitely a faster way to graph this. I'm just giving you an alternative way to do it. So let's use the points 110 and 212. So on my graph, I'm going to go to 110, which is right here, and 212, which is right here. I really only need 2 points, but if you want to do more, it's totally fine. Nobody's going to get mad at you for having extra points on the graph. So let's go ahead and connect these as best we can. There we go. Looks pretty good. And there's our graphed line. And I can see, as expected, that this has a y-intercept of 8 as well. We knew that it would because our b value was 8. And if I count rise over run should be up 2 and over 1, up 2 and over 1, and it sure is. So I've got a slope of 2 in there as well. So two different ways that we can graph this. We could have started at 8 and then counted up 2 and over 1, or we could pick a couple of values for x and plug those in and get a couple of coordinates that way, either way. So we've done both things the problem asked us to do. We have graphed it and we have answered the question that this is not a proportional relationship because a proportional relationship has to go through the origin, the point 0, 0, and this one does not. It goes through the point 0, 8.